Okay, this deals with triangle sums conjectures, where all the angles in a triangle have to add up to 180 degrees. So in this first set of triangles, we can see that the two on the left add up to 113. When we subtract it from 180, we get 67. By vertical angles, the other angle at P has to also be 67 degrees. And 67 and 98 in the right-hand triangle adds up to 165, which gives us 15 degrees for angle Q. So P is 67, Q is 15. In the next triangle, let's see, what do we got? We've got, in one triangle, we've got 28 and 53. Let's just find out that the triangle next to Y, which is a linear pair, is 99 degrees, which means that angle Y, or by exterior angle theorem, is going to be 99 degrees. So I might be off by 1 degree on that one. And then the 82 and 81 and 17 adds up to 180 degrees. And the next one, we have parallel lines cut by transversals. There's two different transversals, so we can do the 23 alternate interior angles, and we can also jump angle B up to inside in the upper right-hand triangle. Using the left-hand triangle, 23 and 79 from 180 is going to give us angle A equal to 78 degrees. So angle A is equal to 78 degrees. And now to find angle B, we can do the linear pair with 79 and get 101 degrees for that other angle, and that with 50 gives us 151, which leaves us with 29 degrees for the measure of angle B. Okay, looking at the next problems then. More parallel lines with transversals. First off, I made a mistake. I thought this 100-degree angle went with those, but actually that 100-degree angle is a vertical angle to that center angle. So I'm going to erase those out and just jump that angle across. That's where the 100-degree angle goes. So in that bottom triangle, we've got two angles left to make up the extra 80 degrees. So each one of those has to be 40. So by alternate interior angles, I can jump the 40 up to the upper right. That 100 with the 40 means that the inside angle has to be 40. By vertical angles, I can jump the 40 across, which gives me the 100 and the 40. So by solving the diagram completely, it's pretty easy to jump those angle measures around. Here we have two triangles that match each other. And we can see then that the angle at X matches with 31 degrees, and that the other angle with the double marks on the arc matches with 85 degrees. So when we find out what angle X is, the two that they give us add up to 116. X must be 64 degrees. And then angle Y, if we match the angles up, angle Y matches the other angle in the other triangle. And if we do 69 or 64 and 85, we end up with, and subtract from 180, we get 64 degrees. Angle X then is 31 degrees. On the next triangle, all three of these inside angles have to add up to 180. But the other thing that we have going on is that we can just express Y in terms of 130 plus 3x. And then by triangle sums, we can go ahead and see what we get in relation to X when we substitute everything back in. We get 10x is equal to 50, so X is equal to 5. So 130 plus 3 times 5 makes 145, which is what Y is. So we found out that X was 5 and Y was 145. Look at the next set of triangles. We want to find the measure of QPT. It's an isosceles triangle, which means that the other angle is also 76 at the base. 2 times 76 is 152, which leaves us 28 degrees for angle S. The other triangle is isosceles for number 8. We've got two angles plus 35 have to make 180. So each angle comes out to be 72.5 degrees. We take away 35 from both sides and get 2 times x equals 145. This other triangle, this is kind of like a puzzle. We can use vertical angles and get C across there. And then by third angles, we know that B has to be the other angle in the middle. Then we have vertical angles and then third angles again. Find the measure of QPT. In that left-hand triangle, it's equilateral, so it's equal angular, so all the angles are 60. And then we can jump that angle across to the right, and we got 60 and 30 and 90 makes 180. And then looking at the other angle inside, it's isosceles, because the congruent base angles, and we have 90 plus 2 x's, means x is equal to 45 for each one of those. So QPT is going to be the sum of 60 plus 45 plus 30, which comes out to be 135. In number 11, we've got our marked angles are actually supplementary to the angles that are inside the triangle. So we can use this theorem that we had a while ago called the congruent supplements theorem, which says that angles that are supplementary to the same angle are congruent to themselves, congruent supplements. So it means like up at the top of the angle, whatever that inside angle is also congruent to the inside angle on the bottom right, since those two outside angles are marked as being congruent. Each one's supplementary because of the linear pairs, but then they're all congruent supplements, which means they all have to be congruent to each other. So 3 equal angles, they all have to be 60 degrees, which means that the supplementary angle must be 120. Number 12, use the diagram to explain why they're complementary. We've got a 90-degree angle, and we've got angle A and angle B. Altogether, they have to equal 180 degrees. Since angle C is right, we know this measure is 90. So A plus B equals 180 take away 90, which means that A and B equals 90, which means they're complementary by definition of complementary. Two angles that add to be 90 degrees must be complementary. Looking at number 13, explain why these angles are congruent. Well, in the center, we have that vertical angle at E. Angle BEA and angle CED have to be congruent because of vertical angles. So let's call that angle X. So we have measure of A plus measure of B plus X is equal to measure of C plus measure of D plus X. If we take X away from both sides, we end up with the measure of A plus the measure of B is equal to the measure of C plus the measure of D. And we've shown what they wanted us to show. And we use the third angles theorem for that one, along with vertical angles.